Let's talk about graphing the tangent function. Tangent function, unlike sine and cosine, it is a wave. However, where sine and cosine is a horizontal wave, like you would normally think of seeing one, tangent is kind of a vertical wave. So what we're going to see is that. So the graph of tangent of x, again, you can graph it in a rectangular coordinate system, plotting points that satisfy the function. Tangent actually copies itself, or what am I trying to say? Repeats itself. There we go. Repeats itself in length period, length pi. So again, the period of the tangent is pi. So basically, if we graph from 0 to pi over 2, the rest of the graph is made up of repetitions of this. So if we look at the angle is 0, then tangent is 0, y over x, right? And I've just listed out a couple of points for us, just so we can see that. A couple of things to know about the tangent function. It is odd. You can notice this because it's symmetric with respect to the origin. The period is pi, repeats itself in patterns length pi. Function's undefined at pi over 2, so there's vertical asymptotes actually at pi over 2, and it's actually undefined at odd multiples of pi over 2. And we're going to see that, pi over 2, 3 pi over 2, 5 pi over 2. We'll see that asymptotes actually occur at these values where the function is undefined. It says below we plot some points from above the listing that we had, and we can see that the graph tangent of x is symmetric to the origin. Again, this is the y-axis, and to know if something's symmetric to the origin is to say that if I have positive x, positive y, then I also have negative x, negative y on that same graph, and you can see that we do indeed have that. It's symmetric to the origin, so again we fill in the rest of the interval from negative pi over 2 to pi over 2. Notice what happens. At pi over 2, 3 pi over 2, negative pi over 2, negative 3 pi over 2, and if I had extended this graph on, you'd see 5 pi over 2, right here, 5 pi over 2, and over here, you'd have negative 5 pi over 2. And what's going to happen is that at every single odd multiple of pi over 2, tangent is undefined, which means vertical asymptotes occur at odd multiples of pi over 2. Now let's talk about one wave of this. Now this is what I meant when I said it's kind of a vertical-ish wave, because here's a wave, and here's a wave, and here's a wave, and here's, right? Because we have these breakage points. We have these asymptotes here. And vertical asymptotes, remember, vertical asymptotes, they never get crossed. So let's talk about just, this section. Let's talk about just one wave. Let's talk about the things that are in one wave, or one piece of it, I should say. If we think about the wave, we have an asymptote here and we have an asymptote here. In the middle, between the asymptotes, we have a point here, and that's the x-intercept. If I break my distance between my asymptotes into quarters, 1/4 of the way in, I have one point at negative a. Halfway in, I have my x-intercept. 3/4 away in, I have another y value of a. If this is the look of my function, a tangent bx minus c. Well, you might be asking, all right, well, how do I know where the asymptotes are? Well, this is all you have to do. Take the inside of the function. Take the inside of the function. Set it equal to negative pi over 2 for one asymptote. Solve for x. Take the inside of the function. Solve for set it equal to y over 2, pi over 2. Solve for x. And this is how we will get our two consecutive asymptotes right here. Take the inside of the function and do a double inequality just so you can get those asymptotes. The pair of consecutive asymptotes occur, again, pi over 2 and at the negative. We're going to come back to this when we look at an example. It'll become much more clear. Again, find points on the graph 1/4 of the way and 3/4 of the way through, because they'll have y-coordinates of negative a and positive a here and here. And then use step 1 through 3 to graph one full period. Let's do an example. Again, remember, anytime you want to graph a trig function, you can always do it by hand, but you can also always check your work with the calculator. So, first things first, here we have, again, it's y equals a tangent bx minus c. That's the function, y equals tangent, bx minus c. Okay, well, I thought I had my... Okay. First, find two consecutive asymptotes. We do this by finding the interval containing one period. Negative pi over 2 and pi over 2. So what do? I'm supposed to take bx minus c, set up my double inequality. Well, bx minus c is the inside of the function. For this one, my inside of the function is just pi over 2, or x over 2. So I'll write here, I'll write x over 2. And then I'll just solve my double inequality. Remember, for a double inequality, what you do to the middle, you must do to both sides. Well, I want to get rid of the 2. It's being divided, so I'm going to multiply it on each and every side. When multiplying on it on each and every side, notice what's going to happen. The 2's will cancel. So basically this says, here are your asymptotes at negative pi and pi. Next, find the point midway between your asymptotes. Well, midway between negative pi and pi is 0. And for an x-intercept, the x is also 0. So that means that my point 0, 0 is my x-intercept. Let me show you a little better, if I can grab my unit circle here. Okay. Now, the question is between pi and negative pi. Thinking of it a different way, think about a number line. What's the number right there in the middle? 0. So here is your x-intercept, right there in the middle. Next, we have to find the points that are 1/4 and 3/4 of the way through. 1/4 and 3/4 of the way through. One thing you might want to think about doing is this idea. For example, from here to here, the whole length, from negative pi to 0 is length pi. From 0 to pi is length pi, which means the whole length here is 2 pi. Half length here would be pi, which means quarter length here would be pi over 2. You can find successive x values simply by doing our quarter length again. For example, we know we'll start with the left. Negative pi plus quarter length. Negative pi plus pi over 2 will get you negative pi over 2. Okay, let's do another one. That tells me the point right here. That's 1/4 of the way through. If I take negative pi over 2, add my quarter length, That's negative pi over 2 plus pi over 2. That gets me to 0. That's what we said the midpoint should be. That's halfway through. Next, if I take 0, add my quarter length, 0 plus pi over 2, that gets me pi over 2. That's at 3/4 of the way through. And lastly, I should end up right here at pi. What pi over 2 plus my quarter length will indeed get me back to pi. This is how you're going to find your 1/4 of the way through and 3/4 of the way through, and your midpoint. So here we just did step 3. We said that, okay, if I know I'm supposed to go from negative pi to pi, we said that 1/4, let's go back to our points that we had, right here. 1/4 of the way through, negative pi over 2, halfway through, and 3/2 way through. So I have negative pi over 2, 0, pi over 2. So 1/4 will be negative pi over 2. 3/4 will be pi over 2. Now, these points will have y values of, plus minus a. Well, remember your original function was y equals 2 tangent x over 2. So if I look at this function, I can see that the absolute value of a is the absolute value of 2, or 2. Now the question becomes, okay, now which one gets it? Which one gets the plus and which one gets the minus? Now, if you recognize tricks of the equations, the graphs, you can figure this out without evaluating. We can always evaluate, though. It's no big deal. So one thing to notice is that your function is starting out positive, which means you should basically have this general shape because you're starting with positive. But that's okay if we don't see that. We can simply evaluate. Let's evaluate our values here. Now, I know at negative pi I have an asymptote. I know at pi I have an asymptote. The question is, well, what happens in the middle? I know that my 0 is my x-intercept, so I'm going to have a point right there. The easiest thing to do is just evaluate your 3 in the middle. I mean, you know what's going to happen at the 0, but that's okay. Take 2 seconds and evaluate it. So I have 2 tangent negative pi over 2 over 2, which will get you 2 tangent of negative pi, which will get you 2 times, let's see, y over x will end up getting you ordered pair, negative pi over 2 and negative 2. Next, 2 tangent 0, 2 tangent 0, 2 times 0, ordered pair. 2 tangent pi over 2 over 2, 2 tangent pi, 2, 1, there we go, ordered pair, Okay, now, let's simply just graph the function now. If we go back to our original problem, it told us to graph between negative pi and 3 pi. So that's what we're going to do. There we go. We have our asymptotes, negative pi, pi. We have 2 and negative 2. We have our midpoint of x-intercept, 0, 0. We have our halfway through, our quarter way through, negative pi over 2. We have our 3/4 way through, so that this is the shape of our wave. Now I'm supposed to go out to 3 pi. Now remember, it was odd multiples of pi over 2. If we evaluate again, we'll find that the next one's going to be at 3 pi. One other thing to remember is that we did this neat little trick right here, where we said asymptote to asymptote is length 2 pi. Okay, that means from asymptote to next asymptote will be length 2 pi. So from pi plus 2 pi gets me 3 pi. I know my half length is going to be length pi, so I know that right here at one more pi over at 2 pi, I'll have an x-intercept. And I know that quarter way through, I'll have another point. This one will be down at negative 2. This one will be up at positive 2. And we continue the shape of the wave. Again, we can always check our work. Okay, let's check our work here. I want to graph 2 tangent x divided by 2. Now remember, if you're not seeing anything, and let me zoom out once this finishes, okay? If you don't see anything on your graph when you graph these, it means that your mode is in degrees and you have to be in radians. Watch, see, here's my mode, radian, and that's why I can see this graph. Notice, does my graph match the graph that we have here? Absolutely. Again, we can always just check our work there. Okay. Let's continue on. Same exact type of problem, just another one, okay? Here we go. Find two oops, you can't see that, can you? There we go. Find 2 consecutive asymptotes. Again, what are we going to do? We're going to take the inside of the function and set in between negative pi over 2 and pi over 2. I do want to solve for x, which does mean I'm simply going to subtract out that pi over 4. So I've got negative pi over 2 minus pi over 4. That will give me a negative 3 pi over 4 to pi over 4. These are my asymptotes to begin with. We want to find the midway point between these two. So again, I have negative 3 pi over 4, pi over 4. I know that there's a 0 somewhere in between here. It'll be closer to the pi over 4. That's not my middle point. What I'm doing is I'm all I want to know is I want to know the distance between these two asymptotes, the full length. Alright, well, if I think about negative 3 pi over 4 to the 0, absolute value of this distance would be distance 3 pi over 4. If I go to 0 to 3 pi over 4, right, this distance, Then from 0 to pi over 4, well, that's distance pi over 4. And 3 pi over 4 and pi over 4 will just get you distance pi. Well, if that's the whole distance, what's the half distance? Pi over 2. Well, if that's the half distance, what's the quarter distance? Pi over 4. Okay. So that means that this is my quarter length. So if I want to find consecutive points, alright, I know that my asymptotes are here and here, but start with this one. Start with this asymptote and start adding your quarter lengths. Negative 3 pi over 4 plus pi over 4, negative 2 pi over 4, simplify, negative pi over 2, take again, negative pi over 2, the one before, right? Plus that quarter length. Negative pi over 2 plus pi over 4 will get you negative pi over 4. Next, take the point again before plus that quarter length. Negative pi over 4 plus pi over 4 gives you 0. So this is your 1/4 point. This is your midpoint. This is your 3/4 point. Okay. So now we can start talking about graphing these points. So I have my, oops, I have my x values, I have my function, I want to get my ordered pairs. Okay. Again, I don't have to worry about what's happening at my asymptotes because I know the function will be undefined. What I want to do is I want to evaluate at that 1/4 point, at that midpoint, and at that 3/4 point. Plugging into our function. Negative pi over 2 plus pi over 4 will get you negative pi over 4. So we have to evaluate tangent at negative pi over 4. This is negative pi over 4. Tangent of negative pi over 4 is y over x, which will get me a -1 ordered pair. Next, tangent, negative pi over 4 plus pi over 4. Tangent of 0 is 0, ordered pair. Ordered pair, negative pi over 4 and 0. Last, tangent, 0 plus pi over 4 is tangent pi over 4. At pi over 4, y divided by x will give you 1, ordered pair, 0, 1, so that I can graph my function. Negative 3 pi over 4 asymptote. Negative pi over 2, negative pi over 4, 0, pi over 4. Pi over 4 was my other asymptote. At negative pi over 4, I'm at 0. At negative pi over 2, I'm at negative 1. At 0, I'm at 1. So here is our graph. Again, we can always check this. Always check your work. I'm going to go to y equals. This time I'm typing in the function tangent x plus pi over 4. And there's my graph. And what I graphed was this section right here in the middle, and it looks exactly the same as what I have. Very good.